Okay, we're going to do one more of these lectures online. This one is to introduce you to cylindrical polar coordinate system. So for most of your work in intro physics courses, you worked in Cartesian coordinate systems. That is just sort of the x hat, y hat, z hat coordinate system. And today I'm going to introduce a different coordinate system that can be useful in certain situations, certain problems that involve rotation. And okay, so let's go ahead and get started. So in particular, what we're going to do today is figure out how to write down position, velocity, and acceleration vectors in cylindrical polar coordinates. Cylindrical polar coordinates. Sometimes people just say polar coordinates here, but I'm using cylindrical polar because there's another coordinate system called spherical polar coordinates, which is different. So this is the main topic today. So, all right, so let's just start off with a diagram to illustrate what this cylindrical polar coordinate system is about. So, in fact, we're going to start with drawing this diagram on top of a sort of typical Cartesian coordinate system. So if this is the x hat direction over here, this is y hat, and this is z hat, then now what we're going to do is, in order to demonstrate to you what the meaning of the cylindrical polar coordinates are, I'm going to first draw a structure on top of this Cartesian coordinate system. The structure is a quarter of a cylinder. Okay, so imagine a cylinder which is centered around the z-axis. So, and I'm just going to draw a quarter of this cylinder, the quarter of it which is contained in this positive x, positive y part of the volume. So that would be the part of the cylinder that intersects the xy plane. And let's see, so now let's draw one edge of that structure. Okay, so that is supposed to look like 1/4 of a cylinder. If you were to draw the complete cylinder, it would go all the way around like this. Okay, so now we're going to be describing the position of some particle that is located on this top edge of this cylinder. Okay, so in